Now that I've placed one area and one inlet, we'll continue to move forward placing additional drainage areas and their corresponding drainage inlets. So what I want to do here is I want to add a new area. Before I do that though, I'm going to go ahead and draw the area that I want to, and using my place shape tool, I'm going to draw the area. So I'm going to grab the place shape tool, and I'm just going to continue from the drainage area CB1 and come up that side of the parking lot, creating my next drainage area. So I've drawn the shape. Now I can continue and define that shape as a drainage area in the drainage program. So from the drainage area definition, I'm going to click the Add Area icon. I'm going to select area CB-2, and I'm going to select that shape and accept it, and it'll calculate the drainage area in acres for me. Now in this case, this area is all pavement, so I'm going to go ahead and just type in the coefficient for pavement. My time of concentration I'll leave at 5. My sub areas I won't have any. In this case I'm just going to leave that blank. And then my computations option, switch to that, hit compute discharge, and come up with a 2.316 CFS in this case. Click apply, and my drainage area CB-2 is added to my project. Next, I'm going to switch back to the definitions tab, and I need to place a node for this. So in this case we can link right up to the edit node dialog or node configuration dialog right from drainage area. Click edit node. If I don't have CB2 in the project, I'll go ahead and add it, and the node configuration dialog will pop up, and I can close the area for now. Now most of the information here will stay the same. For example, the elevations, options, the junction losses, the discharge, all that information will stay the same from structure to structure in this case. But the properties may change, the location will change obviously, and maybe the spread as well. So in my case, the properties, I'm going to use the same type of inlet. On location, I'm going to go ahead and zoom to my low point for this particular area in the upper left corner, and I'm going to place this structure tangent to the edge of pavement. So I'm going to use the tangent to element option, select the microstation element, accept it, and then use the DP button to align it up. Now right now I need to change my angle to 0, and tangent on is actually what I want to use so that it hugs or stays on the element I select. So let's say tangent on element, and you can see it's now locked onto that element. So find the location I want to put it, and I'll data point. That'll place it at that location. The spread information, I'm going to go ahead and change the spread. In this case, before the percent slope and percent discharge, that'll stay the same. My parking lot has a pretty much a symmetrical slope to it, but the width of my spread section will change. So in this case, instead of a 63-foot wide parking bay, these are actually 50-foot wide. So I'm going to highlight the option that's there. I'm going to modify 63 to 50, and then I'm going to click the modify list item icon to change it in the list. My ponded depth maximum, my ponded width maximum, I'll leave those the same. Now my elevations, again, I'm going to leave those the same. You can notice that it picks up the new elevation based on my latest data point location. Junction losses are the same, discharge is the same, and computations, since I already have an area created first this time, the computations will be there. So I'll go ahead and click apply, and I've now added catch basin 2. Now the next section, I want to take a look at adding drainage area 3. So I'm going to zoom back out. Drainage area 3 is located at the upper end of the parking lot. Again, I'm going to place a shape out there for this particular drainage area. Oops, I left out a vertice. So let me go ahead and modify that. And add a vertice right there. So now I have the shape placed. So now what we can do is add another area. So drainage component area add. Area ID, the next available is CP3. Click OK. And just as before, I'm going to select the shape for drainage area 3. Base C value will be 0.93. Again, it's all in pavement. No other land use is necessary. So I don't need any sub areas. Where it says time of concentration, I'm going to go ahead and compute the time of concentration. So you'll notice the drainage dialog will go away. But what I want to do is have it compute the time of concentration for me. Now I have a surface, so I'm going to take advantage of the fact that I have a model surface, a proposed surface here. I'm going to toggle on the sheet flow, the shallow flow, and the concentrated flow. So the 3 different types of flows there. Next, I'm going to go ahead and expand the time of concentration dialog by clicking the arrow. And I'm going to set up some max sheet flow and shallow flow distances. Okay, so go ahead and set up my max sheet flow for 20 and my max shallow for 50 and click apply there. So that will set those values. Now back over on the left hand side of the dialog, my sheet flow method, I'm going to use the Federal Highway. But you notice there's a couple other methods there, the Sealy and FAA method. For the sheet flow in value, I'm going to go ahead and set that, and this will be 0.011. The shallow flow, I'm going to use 0.619 for the shallow flow K value. And then for concentrated flow, my velocity, I'm going to set that to 1 foot per second. Now, as far as defining the path, I'm going to hit the trace option. And what this will do is when I data point over here in the pavement area, it's going to do a downstream trace. Okay, if I've drew my area correctly, it'll do a downstream trace, and it'll come up with the low point, which will be down here where the LP symbol is. It'll go ahead and define the rest of the fields for me. So I set up a maximum of 20 for sheet flow, shallow flow 50, and then the rest, based on this length that it computed, is 151. Now you can see the table on the right, and that's the distances and slopes that it calculated as it went through there, through that path. And I can make adjustments to those and move some and delete some and so forth. So basically when you use the trace option, it does a downstream trace and calculates that distance to the low point, and then from there it figures into the values. So total distance of 221 feet. I'm going to go ahead and hit compute, and it comes up with a time of concentration, in my case, of 3.324 minutes. Now, in order to send that back to the drainage area dialog, I'll go ahead and click apply, and it'll send that value back. I don't have to use that value, but I can override it again. But that's how you use to compute time of concentration. So back at the computations, I'll hit compute discharge. It'll come up with a value in CFS, and I'll click apply, and I've therefore added Catch Basin 3 drainage area to my project.